ሰላም ተማሪዎች እንደምን አላችሁ? ዛሬ ኳንቲፋየርስ የሚለውን ይዤላችሁ መጥቻለሁ። ምክንያቱም ብዙ ተማሪዎች ኳንቲፋየር ግልጽ አይደለም በጣም ያስቸገረን ነው። ስለዚህ ስለ ኳንቲፋየር ብትሰራልን ባላችሁት መሰረት I'll bring this one about quantifier. In case of quantifier means mathematical logic, it shows that which elements in the domain satisfies the given condition we have. Elements ውስጥ which one satisfies the given condition የተሰጠን condition የትኛው satisfy ያደርጋል ወይም አያደርግም የሚለውን በዛው እናያለን ማለት ነው። ስለዚህ የተሰጠንን condition የትኛው element satisfy ያደርጋል. In that case here we have two conditions in case of quantifiers. The first one, that means if it works for all x in the domain satisfies the property of the given condition. In that case, we call that is universal quantifiers. It works for every x or for all x or for each x in the domain. In case of existential means there is an x that satisfies the given condition or there are some x's that satisfies the given condition or there is at least one x that satisfies the given condition. If that's so, we call that is existential quantifiers. Now let us see these examples using the quantifiers, that means universal as well as existential. Or to find the truth value of the quantifiers that p, q and r, they depend on what? One variable x. So if we consider the first one for all x, that is p of x. It satisfies for all x. Is it true or false? It is false. Why? It is false because if we take here x is equals, that is 5. It says that 5 plus 2, that is 7. 5 minus 3, that is 2. 2 times 7, that is 14, is equals to 0. Yes? False. So it works only for what? Thus 0 solves these two factors. Since factor are the p of x. ይሄ ሁለት ፋክተር አለ x plus 2 እና x minus 3 ስለሆነ 0 መሆን የሚችለው መቼ ነው? x negative 2 ሲሆን ወይም x is equals 3 ሲሆን ከዛ ውጭ መሆን አይችልም. So it is false. If say that there exists at least one x p of x, yes, is it true or false? Yes, it is true. Why? It is true when x is equals either negative 2 or x is equals that is 3. Yes, ሲሆን ምን ይሆናል? true ይሆናል. Because of this it is true. When you come to the second one, q of x squared greater or equal 0. Consider this one. What can you say about this for all x q of x? For all x q of x satisfy ያደርጋል አያደርግም? ለሁሉም xዎች ስንወስድ x squared greater or equal 0. Yes, it is what? True. Why? Because square of any real number. Any real number is ምን ብለናል? is non-negative ስለሆነ we call this is ምን ይሆናል? true ይሆናል ማለት ነው። ማንኛውም number square ስናደርገው ምን ነው ብለን non-negative ነው መሆን የሚችለው 0 or positive real number ስለሆነ yes it is true ይላል። What about there exists? Yes, it works. There exists x that is q of x. What about this one? It is true. That means if for all x q of x is true, automatically this implies that it works for existential. ለሁሉም x true የሚሆን ከሆነ existential ምን ይሆናል ማለት ነው? It is true. No doubt about this. Let's come to the third one. It says r of x squared less than 0. What can you say about this? For all x, r of x is true or false? Yes, it is what? False. ለምን? We say here is the square of n real number ምን ብለናል? non-negative ነው ብለናል። እዚህ ጋር ግን ምን negative ነው? x squared less than 0 means it is negative. So it is false. It is false. We can't find any x whose square is negative. Square negative የሚሆን ምንም አይነት real number ማግኘት አንችልም. Because of this it is false. At the same time there exists x that is r of x. Can you find any x whose square is less than 0? No, we can't find. It is false. So if it is false for all x, we can't find any x that satisfies what? That satisfies x square less than 0 የሚሆን ማግኘት አንችልም። ለሁሉም xዎች false ከሆነ existential ምን ይሆናል ማለት ነው? false ይሆናል ማለት ነው። Quantifier ማለት that means which element of the given domain satisfies the properties of the open proposition, that is p of x, q of x, r of x. ቻናሉን subscribe, like, share ማድረጋችሁን አትርሱ። In case of universal quantifier, it says for all x, it means that it satisfies the given condition for every x or We can say for all x or for each x. It is noted by this inverted ax p of x reaches us every x in the universal has the property p. If you take n x, then it satisfies the property of that is p. As I told you before, in case of existential quantifier, there exists an x. That means there exists one x, or there may be some x's, or there may be at least one x. Both all are the same. Satisfies the given condition. That's so we call that is existential quantifier. In case of universal quantifier, you'll try to find at least one value that makes your statement false. Then we can say that the truth value is always false. In case of existential, you will try to find at least one x that satisfies the given condition. In that case, you can say that the truth value of that existential quantifier is that is true, we can say. And it is denoted by inverted e x p of x reaches as there exists an x or some x or at least one x in the universal that satisfies the given property p. That's so we call that is existential quantifier. The other one is we can combine quantifiers if have the preposition p depends on two variables x and y. We can combine as forms for all x, for all y, p of xy. That means every x and for every y that satisfies the property of p at the given universal. Similarly, there exists x, there exists y, there is at least one x and at least one y that satisfies the property of what? P. In case of this one, for every x, there exists at least one y that satisfies the property of what? P. In this case, it says there exists at least one x for every y that satisfies the property of p under the given universal. So we have to combine quantifiers as such forms. If it is a p, preposition p depends on two variables x and y. In case of 3 also, you have to extend it this one. Now let us this with example. It says that p of x y 2x plus 2y is equals 1. So let us consider the four options that work. That means for all x, for all y, this is one option. The other one, for all x, there exists y. This is other. The other one is there exists x for all y. This is the other option. The other one is there exists x as well as there exists y that satisfies the property of what? The given condition we have. So we have this four options when you combine a quantifier with p that depends on what? Two variables x and y. Now let us consider this. It says that p of x comma y 2x plus 2y is equals 1 and p of x y 2x plus 2y is equals 6 when the universal is what? In both cases that is integer. If we consider the first one, it says for all x, for all y, the property that is p of xy we can say here. How can we perform this? Is it true or false? You have to take any arbitrary x and y since it says for all x and for all y that satisfies this condition. If you take this is what? Is it true or false? It is false. Why it is false? Because let us take x is equals 1. Let's take y is equals, you have to take here is 1. Then what for? This shows that p of this 1 with 1 says that 2 times 1 that is 2. Plus 2 times 1, 2. 2 plus 2 that is 4 is equals to 1. That because of this it is false. By considering any arbitrary value, you can check whether it satisfies or not. This is the first one. What about the second? Let's take this is for all x there exists y says that satisfies property of p of x y. What about this? Is it true or false? You have to consider this. For every x there exists y, p of x y satisfies this condition. Let us check this. It is what? True or false? I think this is false. Why it is false? That means this shows that for every x we can take any x. For instance, any x. For x we can find what? This shows that 2y is equals to 1 minus that is 2x. So divide both sides by 2. This shows that y is equals to 1 over 2 minus x. So this fails. When you take any x, y cannot be integer for these particular cases. Because of this, this is false. Since for every x, y is equals to 1 over 2 minus x. This shows that if you take any x in 1, that means 1 over 2 is not integer, so the difference between 1 over 2 minus x is always, this is not integer. Because of this, this is false. What about the next one? The next one, that means we have there exists x for every y such that satisfies the property here is p of x, y. Here. What about this? This is also analogous with the second one, it is false. In case of the last one, existential, there exists x and there exists y, p of x, y is what? That is false. It is what? False. We denote it is false with f, true with t. So it is always false. We can't find at least one x that satisfies this condition. 2x plus 2y is equals 1. We can't find at least one x and y that satisfies this condition. Since x plus y cannot be equals, can find that? You have to check this one. If you take here is x, this is 1, 2 times 1. This y is negative 1, so it becomes 0. Well, so we can't find any x and y that satisfies this condition. Because of this, in all cases, this statement p of x, y, 2x plus 2y is equals 1 is false for x and y in the universal that is integer. Now let us consider the next one. 2x plus 2y is equals to 6. Here we have a common factor that is 2. So we can divide both sides by 2. This is equivalent to x plus y is equals to, that is 3. Or we can take it as it is. Now we can check what can say about the first one. For all x, for all y, p of x. As we said before, that means is it true or false? It is false. Why it is false? We can take any arbitrary x and y since it says that for all x, for all y. Any arbitrary. That means let's take x is equals 0, y is equals to, we can take here is 5, arbitrary sample. You see, in this case 0 plus 10 is equals 10, 10 is equals 6, it is false. The second case, if we consider for all x, there exists what? Y, at least one y that satisfies this p of x, comma y. Here. Is it true or false? When it comes to here, it is true. Why it is true? This shows that for any x, we can solve here is y. What for? This means 2y is equals 6 minus 2x for any x we have. For any x. It shows that what is y? Y is equals, divide both sides by 2. This means 6 divided by 2, that is 3. Minus 2x divided by 2, that is x. So, when you take any x here, we can find a corresponding what? Y. So, for any x we have, we can find any corresponding y for this one. Take for instance, x is 3. So, y becomes 3 minus 3. Yes, we have at least one y that satisfies this condition. We take here is x is equals 5. 3 minus 5, that is negative 2. Yes, we can find y. So, this is true. When it comes to, it says there exists x. You know the difference between this one. There exists x for all y. The property that is p of x, y. Is it true or false? When it comes to here, there exists x for all y, p of x, y. You know, it shows that there is one x or some x's that satisfy for all y we have. Can find this. This shows that you have to find y. This means 2y is equals to 6 minus twice of x naught. You know, you'll try to find what? At least one x that satisfies for all y. This shows that what is y? Y is equals to 3 minus x naught. You know, you can consider x naught for instance, as we said, that is 3. 3 minus 3, that is 0. This 0, that means 3 is not corresponding with 4 or it doesn't satisfy for all y we have. 3 ለምሳሌ ዝብነው 3 ሲቀነስ 3 እና 0 ይሆናል። ያ ማለት 3 ሲሆን x ኖት y ስንት ይሆናል? 0 ነው እንጂ መሆን የሚችለው 3 ሲሆን ለሁሉም y መስራት አይችልም። Because of this statement that is called this is false. This is for a fixed x naught. Not only one, you have to take 2 or 3 of x's. They may not satisfy for every y. ለሁሉም y ግን satisfy አይደለም. Because of this, that is false. እዚህ ጋር ያለው difference for all x there exists y means what? Y depending on what? Y is depending on x. You see, first you have to take any x, then you'll try to find at least one y that satisfies the given condition. Here one. But the case of this one, you'll have what? One x that satisfies for every y. የኛው የሚያሳየው ምንድነው? አንድ x ወይም some x's that satisfies for every y ነው የሚያሳየው። የኛው ግን for every x at least a one corresponding y ማለት ነው። ስለዚህ are different የተለያዩ ናቸው ማለት ነው። Next one, let us see. There exists x that satisfies there exists the other y that satisfies the property p of x, comma y. What about this? You have to take this. Some arbitrary value for this. You have to take this is what? Is it true or false? It is true. Because there exists existential. There exists at least one x and one y that satisfies this condition. Yes, we can take x here is 0, y is, let's take 3. You see, 3, this one is what? You can take 0. You can examples. You have to have the here is 4, take this one, negative 1. So we have different example on this. Because of this, the truth value for the existential for both cases x and y that is true. ስለዚህ በዛ አይነት መንገድ ሌሎችንም ማሳየት እንችላለን ማለት ነው። So ቻናሉን ሰብስክራይብ፣ ላይክ፣ ሼር ማድረጋችሁን አትርሱ። Let us see the next one. It shows that for any non-negative integer x and y determine the truth value of the following. X and y are non-negative. What can you say about this? For all x, for all y is greater than x squared minus 1. In this case, for the case of for all x, for all y, nothing is done. Take any arbitrary values. For instance, here is x is 3. Let's take y is equals to 1. Yes, x is 3 is non-negative. Y is equals 1 also non-negative integer. Now check that whether it satisfies or not. This is y. 1 is greater than 3 square means here is 9 minus 1. This shows that 1 is greater than 8. This implies that it is false. Because of this, for all x, for all y is greater than x squared minus 1, it is false. It is false. Since it shows that, or it says that, for every x and for every y is greater than x squared minus 1, for x and y are non-negative integer ነው የሚለው። ስለዚህ ማንኛውንም arbitrary number መውሰድ እንችላለን ማለት። But when you take x is equals 3 and y is equals 1, the statement what? ምን ሆነ? false ሆነ. So it doesn't work for all. In case of for all x and for all y, ምን እናደርጋለን? We will try to find one point, at least one point that make our statement false. ማድረግ የሚችል statementታችን false ማድረግ የሚችል one point ካገኘ we can say that is false. Let's come to the second one. It says there exists x for all y is greater than x squared minus 1. What does this imply? Is it true or false? There exists one x for every y that satisfies that y is greater than x squared minus 1. This is true. Why it is true? For instance, take x is equals to 0. This shows y is greater than 0 squared minus 1. What does it imply? This is y is greater than negative 1. You see? For every y is greater than negative 1. Why? Because x and y are non-negative integer. That is true. Always is true. Why? Because we obtained 1x is equal 0 that satisfies this condition. ለምን ሆነ? ለምን y is non-negative integer ስለሆነ 0 1 2 3 ያለ that means y is always greater than what? A negative integer. Particularly here is negative 1. Because of this statement becomes true. Now let us see the next one, the continuity of this. It's so that there exists x, there exists y. Say that y is less than or equal x squared minus 1. It shows. Confirm here. Since this is existential, we can find that satisfies this condition. Let's take this is the truth value of this one is true. Why it is true? Take here is x is equals 1. Then the value y is equals, let's take here is 0. This shows that 0 is less than or equal 1 square minus 1. This means 0 is less than or equal 0. Because of this, by taking this sample 1x and 1y that satisfies this condition, since this is existential, that means we will try to find at least 1x and 1y that satisfies the given condition. Because of this, it is true. You can consider another example too. For instance, x is equals, that is 3, so y is equals 2. We can consider this one, the other example. This shows that y that is 2 is less than or equal 3 squared minus 1. This means 2 is less than or equal 8. Yes, it is true. No need of finding two examples. ሁለት ኤግዛምፕል መፈለግ አይጠበቅብንም. There exists y ስለሆነ 1x 1y that satisfies this condition ካገኘን we can say that is true ነው ማለት የምንችለው. Because of this statement is true. What the next one? It says there exists x for all y is less than or equal x squared minus 1. There exists 1x for all y is less than or equal x squared minus 1. What can you say about this? In this case, can find 1x that satisfies this condition. You have to take here is y is less than or equal, let's say x naught minus 1. For a fixed one for fixed or 1x naught. That means, is it true? No, it doesn't work for all y. If y is 9 or 10, whatever the case, in that case it is not less than. Because of this, it doesn't work for all x. But it works at least 1x, 2x or 3x. It works for minus 1 is የኛው ሊሆን አይችልም። አንድ ፊክስድ x ለሁሉም y is less than or x square minus 1 ሊሆን አይችልም። We can't find 1x that satisfies for all y. ይህ ማለት ነው y is less than or equal x naught square minus 1 for a fixed x naught. But this x naught doesn't work for every y we have. ለሁሉም y የኛው ሊሰራ አይችልም። ለምን? If you take 3 ብትወስዱ 3 square ማለት 9 ነው። 9 minus 1 8 ይሆናል። ስለዚህ y is less than or equal 8 ነው። But it doesn't include every y include ማድረግ ይችላል አይችልም። ይሄ y include ማድረግ የሚችለው 0 1 2 3 4 5 6 7 8 ይሄንን ብቻ ነው። ነገር ግን y greater than 8 ከሆነ it fails. Because of this it is false. Let's add the same problem. There exists x for all y, because here is y is greater or equal x square minus 1. We can consider this. What about this? What about the truth value of this? There exists x for all y is greater or equal x square minus 1. Is it true or false? What can you say about this? It is true. Why it is true? We can find here is 1x naught. That means for x naught, which is element of non-negative integer. That means non-negative integer. Non-negative integer means what? Which is equals z plus union. It includes 0, yes? Here what? Is that so? This shows that y is greater or equal x naught square minus 1. From this domain, we can take x naught, for instance, that is 0. This shows y is greater or equal 0 square minus 1. This means y is greater or equal negative 1. Is it true or false? It is true. Since y is the value of y is what? 0 and positive integer. When you take 0, yes, 0 is greater or equal negative 1. When you take 1, yes, it is greater than. When you take 2, yes, it is greater or equal negative 1. Because of this, it is true. This is one option. The other option we have, let's take x is equals, for instance, 1. X naught, for instance, 1. So, this shows that y is greater or equal 1 square minus 1. This shows y is greater or equal 0. y minimum መሆን የሚችለው ስንት ነው? 0 ነው። ካልሆነ 1 2 3 እያለ ይቀጥላል። So 0 greater or equal 0 ነው። 1 greater or equal 0 ነው። 2 greater or equal 0 ነው። ለምን? yአችን non negative integer ስለሆነ። ስለዚህ there exists x for all y greater or equal x square minus 1 የሚለውን satisfy የሚያደርግልን 1x ካገኘን for every y we can say that is true. There exists x means it may be what? 2x ሊሆን ይችላል 3x 4x or what? At least 1x ሊሆን ይችላል. Let us see. It says that p of x times y is equals 1 where both x and y is a set of positive rational number. If it is positive rational number, what can you say about for all x for all y? Here what? For all x for all y of here is p of x y. Does it work for all? You can consider this. Is it true or false? That is false. Since it says that for all x and for all y, we can take x here is 1, that is 2, y is equals, we can say here is 1. Take this sample. In that case, this shows that 2 times 1, that is 2, is equals 1. It is false. What about the next one? We can take for all x, there exists y, that is p of xy. Satisfy this property. What does apply? For every x, we can take any x, then y becomes the true or false. That is true. Why? It is true. For every x, y is equals 1 over x. Yes or no? Yes. You can take any x, then we can find y as a forms 1 over x. Take any number. ማንኛውንም x ስንወስድ ምን እናገኛለን? y is equals 1 over x ይሆናል። ያ ማለት ማን ነው? corresponding y ማግኘት እንችላለን ማለት at least 1 way. Because of this, it is true. The next one, what found? That is, there exists x for all y. Alright, that is p of xy. What about this? Is it true or false? It is false. Why it is false? That means there exists x for every y. That means this shows that y is equals to 1 over x naught. Since we have what? 1 x naught or at least 1 x naught that satisfies for everyone. That's it. It is false. We can take here is x for instance 2. This means y is equals, this is 1 over 2. This 2 is not corresponding for every y. ለሁሉም y መሆን አይችልም። 2 መሆን የሚችለው corresponding with what? 1 over 2 for y, 1 over 2 ነው እንጂ መሆን የሚችለው ሁሉንም y correspond ማድረግ አይችልም. Because of this, it is false. There exists x and there exists at least one y that satisfies p of xy. What about this? It is true. You can take. Since it is non-negative, you have to take x is 1, y also 1. Sample. You have to take x is equals 1 as well as y is equals 1. 1 times 1, yes, it is true. You can take x is equals 3 and y is equals to 1 over 3. Yes, it is true. So, because of this, this one is true. But the first one false, the second is true, the third is false, then the last case that is existential case that is true. ማለት እንችላለን ማለት በዚህ አይነት መንገድ ማሳየት እንችላለን. Let us see the next one. It says that the same problem with x is element of real number except 0 and y is element of real number. What about this? It shows that is the same problem. P of x comma y says that x times y is equals 1 with x element of real number except 0 and y is element of what? Y is element of real number, it says. So, when you consider the first one for all x and for all y, P of xy. What about this? In this case, to check this, you have to take any x and y from the given domain. X is except 0, y is a real number. So, because of this, we can take it is false. Yes? Why it is false? Because take x for instance, it is 1. Take y is equals to, that is 0. We can consider this one. So, 1 times 0, that is 0 is equals 1. This shows that 0 is equals to 1. Because of this, it is false. This is the first case. The second case, it says for all x, there exists y, at least one y, says that satisfies properties of p of xy. What about this? Is it true or false? You can take any x and find the corresponding y. This is why it is true. Take any x. Then what is y? Y is equals to 1 over x. Yes, it works. Why? Because x is different from 0. X is all real number except 0. Because of this, it works. Since x is non-zero or x is element of real number except 0. This shows that we can find any reciprocal of x. If x is different from 0, we can find. Because of this, it is true. Next one, it says there exists at least one x for all y. Says that what? P of xy. It shows this. What about this? Is it true or false? It is false. You see? You can take a fixed x. That means take x naught. Here what? Take let x naught. It shows that what about y? Y is equals 1 over x naught. This means it must work for what? For all y. ለሁሉም y መስራት አለበት. X naught. But it doesn't work. For instance, if we take x naught is different from 0, take here is any fixed x naught, but it works for what? Or y? Take x naught is equals 2, for instance. It works 1 over 2. Yes, y is equals 1 over 2. This means 2 works only for what? A corresponding value for 1 over 2, not for all. Similarly, if we take any number here, we can't find value 0. ማንኛውም fixed x ወስደን we can't find y 0 ማድረግ አንችልም. Because of this is false. False ይሆናል. Last one, existential. There exists x and there exists y. Say that the property that satisfies p of xy. What about this? It is true. This is true. Take any arbitrary number that satisfies this one. Not arbitrary. Some fixed value x naught and y naught that satisfies the given property. Yes, we can find. Take here is x for instance, that is 3, and y is equals 1 over 3. Then their product becomes 1. Because of this becomes true. So we will try to find the truth value of this one by considering the properties what meant by for all x for all y. In this case, በሁሉም x ለሁሉም y ይሰራል። ይሄ ፕሮፐርቲ ሳቲስፋይ ያደርጋል ስንል one point that makes the statement false የሚያደርግ ካገኘን we can say that is false ማለት እንችላለን. In case of for all x there exists y means what? P of xy, you take what? Nx, and if there is a possibility to find a corresponding y in terms of x መግለጽ ከቻል that case we can say that is true ማለት እንችላለን. ካልሆነ ግን it is false እንላለን. In case there exists x for all y, P of xy means what? You try to find at least one x that satisfies every y for every y የሚሰራ ነው. ግን can find this y is equal 1 over x naught ይሆናል. This x naught ስንወስድ you have to have a corresponding value y is equal to what? 1 over x naught ነው እንጂ ማግኘት የምንችለው 1 over x naught doesn't include or what? Substitute ወይም ሊተካ አይችልም. ሁሉንም y consider ሊያደርግ አይችልም. 1 over x naught ማለት ሁሉንም yዎች አይወክልም ማለት ነው. ሁሉንም yዎች መወከል አይችልም. Because of this is false እንላለን. There exists x, there exists y ስንል ግን we will try to find ምን እናደርጋለን? at least 1x and 1y that satisfies the given property ማግኘት ከቻል true እንላለን ማለት as this question. Let's say this is p of x y, x is less than or equal y, where x is element of real number, y is element of real number. For all x, for all y, for this one. In this case, you have to take arbitrary x and y. Since it says for all x and for all y, we can take any arbitrary x and y. It is false. Why? Take x is equals, for instance, 5 over 2. Let's take y is equals to 1. We can take this. This shows 5 over 2 is less than or equal 1. Is it true? It is false. So take one arbitrary sample that makes the statement false. The next one, it says for all x there exists y, says that p of xy. What can you say about this? ማንኛውንም x ስንወስድ ምን ይኖርና there exists at least one y that satisfies x is less than or equal y. Take any x. Is it true or false? It is true. Take any x here. Any x. So this shows that x is less than or equal y. Since y is an element of real number, x also an element of real number, for any x we can find what? Larger number y in R. Yes? You have to take arbitrary sample for this one. For instance, if you take 3 less than or equal, take y value that is 4, yes? Or 10. Take any value that means 1 million. We can find a number which is greater than 1 million in the real number. Real numbers ከ1 million የሚበልጥ number ማግኘት እንችላለን. Because of this, it works for all x. ማንኛውም x has a greater value in same real number R. ማንኛውም ቁጥር ምን ማለት ይችላል? ከሱ የሚበልጥ real number ማግኘት እንችላለን. Is that so? It is true. The next one, it says there exists x for all y. You see, that satisfies p of xy. What can you say about this? Is it true or false? There exists 1x for all y. Can you find a fixed x or 1x or some x's that satisfy x is less than or equal y? It is false. We can't find 1x that satisfies this one. That means take any x naught. Here one. X naught. This means x naught is less than or equal y. ምን ማለት ነው? አንድ x naught ከሁሉም real numberዎች የሚያንስ x naught ማግኘት እንችላለን ወይ ነው? ለሁሉም የሚሰራ. We can't find one x naught that satisfies such property. And property የሚያሟላ ማግኘት አንችልም. ለምሳሌ if we take here is -3 ብንወስድ is less than or equal for all y. y is element of real number ስለሆነ -3 ከ-3 የሚበልጡ ቁጥሮችን ነው እንጂ መስራት የሚችለው ለሁሉም y መስራት አይችልም. It doesn't satisfy the other y's. For instance, y is -4 since y is the element of real number. Because of this, if we take this y is -3, it works. If y is -3 over 2, it works. But if we take y is equal -4, -3 less than or equal -4, it is impossible. Because of this, it is false. The last one, in case existential, there exists x, so there exists y that satisfies the property of p of xy. It says, what about this? It is true. It is true. We can find arbitrary sample for this one. Take, for instance, x is equals 5, this is equals x, and y is equals to, take the same 5. So 5 is less than or equal 5. Yes, it is true. Take here is x, for instance, here is 9. Y is equals to 100 divided by 3. We can take this. Again, 9 is less than or equal 100 over 3. Yes, it is true. ስለዚህ በዛ አይነት መንገድ ሌሎችንም ፕሮብሌሞች ትሩዝ ቫልዩ መፈለግ ትችላላችሁ። ቻናሉን ሰብስክራይብ፣ ላይክ፣ ሼር ማድረጋችሁን አትርሱ። ማንኛውም ጥያቄ ካላችሁ ኮሜንት ላይ አስቀምጡልን። መልካም ጊዜ እንደሆነላችሁ እመኛለሁ። ባይ ባይ።